Hello. Hi, welcome. Welcome everybody to the webinar of theoretical physics today. So here we are on the camera, and then we have another um, colleague or student in chat. So I am Umut Gürsoy. I am a faculty member and also the master program coordinator, along with Joost de Graaf.
And I am Ferran Moral. I am a second year student in the master and also a student ambassador together with Lotte, who is going to be together with us in the chat today.
Yeah, so the story today is, we'll just welcome you, tell you a little bit about Utrecht, about our program, what you do in the first year and second year, and what are the kind of different extra options that you have, different profiles, different courses that you can take from other departments, and what you can do after graduation, and how we can help you with that. And also, of course, about the application procedure a little bit, just about the deadlines and stuff like that. And then after that, we will have a QA session. So this is will be the center of your studies, and I hope not the center of your life always. So this is the Utrecht Science Park, the campus where you're going to study. Well, so some of the dorms are here, and definitely our physics department is here. So mathematics is here, chemistry is here, all the science is here, and this is essentially like really just 10 minutes or 15 minutes walk or 5 minutes bike distance from the center of Utrecht. So although it looks like it's surrounded by the highways, it's not really far away from the center. It's just 15 minutes far away from the center. And well, Utrecht is, as most of you know, is the center of the Netherlands. It's right in the center. This is one of the special features of Utrecht. So it's a very old town. It's a very beautiful town, as you can see from this that picture. That is the academic building, the old academic building, one of the oldest buildings in town. And well, I guess Ferran can say a little bit more about Utrecht.
Indeed, Utrecht is a really nice city, especially for students and for young people. And it has a very big international community. So it's really interesting, especially the nightlife. So if you happen to come here, you're going to enjoy it a lot. Yes.
So here we go. This is essentially, okay, so now enough for the nightlife. So this is the study program of theoretical physics. So it is divided into 2 different years. As you can see, like in the first year, what you do mostly is you take the mandatory courses and the elective courses. So we have 3 mandatory courses: quantum field theory, statistical field theory, and in the second year, we have also the mandatory course called the student seminar, where you learn how to present your results, your research, for example, your master research, things like that. And so on top of these 3 mandatory courses, 2 of them are in the first year. You have the 3 elective courses from theoretical physics. I will just give some examples of what kind of courses that you can take later on. And then you have to take 1 elective mathematics course from our mathematics department. And on top of all of this, you have to take 2 elective natural science courses that can be from any of the GSNS, Graduate School of Natural Sciences programs, like for example chemistry, from biology, whatever. And so in the second year, so this is the normal procedure. So you just in the first year you take the courses. In the second year you start your master thesis, and you take like 70% of your time is going to be essentially spending time on research, reading, doing research, doing calculations, and writing your thesis. And well, also at the same time you can take a couple of courses, for example 1 elective course or something, and then you do also the student seminar. Most of the students do the student seminar in the second year. So this is the normal how it goes. But if you're really ambitious and if you want to do something more on top of all of this, you can do, for example, honors. So the honors can be done with mathematics. Most of the time, people in theoretical physics, the students do it with mathematics. There you have to take a little bit more courses from mathematics, obviously. And at the same time, you have to do research also in the second year, research on mathematics. So one subject in mathematics. So you have 2 options. You can either pick up a subject which is interest to both theoretical physics and mathematics, and you can have 2 supervisors, or you can do 2 different theses. So these are 2 possibilities. So well, let's give a little bit more detail about the study program. As I said, in the first year, you are going to take the obligatory courses and some electives. So the the basic examples of obligatory courses that you have in the as I said already in the first year are the quantum field theory and the statistical field theory and student seminar. So you may be interested in condensed matter physics, you may be interested in particle physics, whatever, but you all have to take these basic courses in quantum field theory, which is mostly used in particle physics, but also in condensed matter. This is a very important subject. Same for statistical field theory in the second year student seminar, which is also extremely important for your, for your presentation skills. And on top of this, well, kind of like coupled to the student seminar, if you like, there are 0.5 EC courses that you have to take. These are GSNS Masters Introduction. So this is just happening at the first, when you first come, the first week of your studies, and this is just like one-day event. And there is also the dilemmas for the scientists, which is a one-day course that you have to take. And again, together with the student colloquium in the second year, we have the student seminar. In the second year, we have the theoretical physics colloquium, where you have to attend at least 18 times. But this is you don't have to think of this as something really obligatory. It's really fun because this is like the really good people come from all over the world and present the front edge research they do, and you will have the opportunity to interact with these guys. All right. So a couple of examples of the high energy physics elective courses that you can take. So, for example, in high energy physics or low energy physics, depending on what you want to do in the second year, you can take the field theory in particle physics, which is mostly about standard model and a little bit of beyond the standard model in particle physics. And then cosmology is one of the courses, one of the most favorite courses of our students. And there's string theory, of course, like string theory as usual. It's a very important course. And in low energy, we have the analog of the field theory in high energy physics. So field theory in condensed matter physics, and we have the soft condensed matter physics course and modeling and simulation. So these are just examples. There are many more courses that you can take, but these are most of the time students take these basic ones. And maybe Ferran wants to say.
Yes, indeed. Later on, you will see some examples, but for now, my experience, for example, I take the field theory in particle physics, cosmology, and string theory too. But on top of that, I also took a philosophy course, philosophy on space and time, really interesting. A mathematics course, which was continuum mechanics. Another, which it's called advanced topics in theoretical physics. So the possibilities are very, very open, and you can choose your way as you like. So you don't have to only focus on one thing if you want.
Yeah, and as examples to mathematics electives, for example, you have well, you can take any mathematics course from the master's program. Yes. If you are, if you're really mathematically oriented, you can build up your knowledge towards mathematics by taking master's courses. But if you don't feel, that you know all the basic things in mathematics to be able to do theoretical physics research, then you can also essentially just strengthen your basics in mathematics by taking bachelor courses. Some of the bachelor courses are possible to take. So we have a list of all these courses, and if you have questions, I can send you the list. So, for example, complex functions, topology, and geometry, or stochastic processes, and all of these courses are from bachelors, and you can take them. Okay, on top of all of this, there are the option of taking external electives. For example, you can take a course from, say, Amsterdam, which is not really far away, by the way. It's just like 20 minutes by train. So you can take a course from University of Amsterdam or from Leiden or whatever, which are not taught that year, say here, which is about, it can be something about the special topics in advanced quantum field theory or something like that. Or you have the option of taking a course from, every year we have a consortium called Delta ITP between Leiden, Amsterdam, and Utrecht University. So we have these short courses on special topics like conformal field theory or whatever advanced topics that we have. So these are also possibilities to take. And you can get ECTS for those courses. Okay. Yeah, so a little bit about the structure of the courses. Well, this is a slide that is essentially, it's really easy to imagine that, we have the courses are structured in the usual way. So we have the lectures and we have the problem solutions. So essentially, one difference that Utrecht makes here is that the problem sessions are quite important. So we have problem sessions for every course, and they are very important. Maybe
yes, indeed. I think we have some Spanish students here, and I come from Barcelona, so my experience is really different from Barcelona to here. In Barcelona, at least, we happen to have like 3 hours of lectures per week, more or less, and 1 hour of problem solving, where usually the professor solves the problem and you just see or ask questions. Here it's very different. Here you have, I don't know, it's around 2 hours.
So we have like
week.
1.5 hour in total per week, say quantum field theory, and then we have like 4 hours of
4 hours problem solving, where you are solving the problems there with your colleagues and other PhD students usually that are
the teaching
working with you.
The teaching assistants
So
work.
it's really
and
nice.
also the lecturer comes from time to time to check
Yes.
if everything is all right. So this is
And I think it's really important because it's what really prepares you for exam and for later research.
So you really get your hands dirty in order to learn things better. And then of course we have well, how they are graded the usual way. So we have usually a midterm exam, we have a final exam, we have handing exercises. The percentage of those, of course, changes from course to course. So these are for the standard courses. For the theoretical physics colloquium and the student seminar are different, of course. In the student seminar, what you do is you just form little groups with your friends to essentially focus on a particular subject, and this main subject can change every year. But there's going to be one subject in high energy physics, one subject in low energy physics, and you can choose. And then you will just do some research with your friends, and then you prepare some presentation, and also you prepare a report. Like you can think of it as doing it's a mock research that you just learn stuff and do your calculations and then present your results and then write a small paper. You will learn all this how this academia works essentially. So, and as I said, like this student seminar is coupled with the theoretical physics colloquium. There's the colloquium 1 week, the other week there is the student seminar. It goes like this. And in the theoretical physics colloquium, as I already said, you have to attend 18 times at least, but that's really fun. So, the second year is going to be research, and that's why you are coming here. This is all, you're building up, you're taking all these courses to essentially come to this point to start doing research. And so, basically, our faculty in Institute of Theoretical Physics is divided into two parts: high energy physics and condensed matter, which can further be divided into hard condensed matter and soft condensed matter. So in high energy physics, we cover most of the subjects like string theory, elementary particle physics. That includes standard model, beyond the standard model, QCD, quantum chromodynamics, and black holes and cosmology. The history of universe, early universe physics, they're all related to each other, of course. And in condensed matter as well, so we cover most of the important subjects like superconductivity, high TC superconductivity, spintronics, topological insulators, all these, and quantum computing, all these interesting subjects. In soft condensed matter physics, we have examples are nanoparticles, liquid crystals, glasses, and and active matter, blue energy. All these things are being covered. So you have the opportunity to do research on all of these subjects. So here are our staff at the Institute for Theoretical Physics. So we have the first guy on the left is Stefan Mandoran. He's a string theorist. He's a black hole expert. Next, there's Bernard David, who's just one of the essential inventors, if you want to for most of the interesting stuff in supergravity and string theory. So he's half time at NICEF, half time here, but he's teaching the field theory in particle physics course. And guy on top in the middle is I guess you have to know him. You should be knowing him. So it's Gerard Toft, our local Nobel Prize winner. And he's these days he's interested in the fundamentals of quantum mechanics. He's always interested in black holes. And next to him, there's Tomislav Prokopec, our theoretical cosmology expert. And finally, on the first row, we have Eric Lanham, who is a particle physicist. He is doing the QCD mostly calculations, and he's part-time at NICEF, part-time here. NICEF is an institute in Amsterdam. It's just next to the University of Amsterdam, which is, as I said, not far away. And then there's me. I'm a string theorist applying string theory to realistic systems most of the time. There's Thomas Grimm, who is also a string theorist, but he's mostly doing more, fundamentals of string theory. In mathematics, is more mathematically oriented, like F theory and all those kind of stuff, if you want to know. And there's this question mark there, and we put that on purpose because we are at this moment, this week essentially, we are in the process of hiring a new cosmology, a theoretical cosmologist. So there will be another cosmologist coming next year. So you will have the opportunity to work with a fresh guy also. All right, so this is for the high energy physics. For the low energy physics, we have René van Rooij, who is mostly interested in the soft condensed matter. We have Hank Stoff, interested in wild semimetals and more hard condensed matter. Christiana de Morais-Smit, interested in topological insulators and again hard condensed matter physics. Paul van Scott, who is part-time in Eindhoven and partly here. He's a soft condensed matter expert, biophysics also. There is Joost de Graaf, who just joined, like last year, he joined our faculty, and he's a soft condensed matter physicist as well, interested in all kind of active matter, for example, and biophysics as well. Carmine Ortiz, again, topological insulators and related stuff like hard condensed matter physics. Dirk Schurit, mostly interested in, like the small systems and mathematical integrable models in condensed matter physics. Lars, again, topological insulators or kind of hard condensed matter physics like that. And finally, we have Ran Bertijnen, who is our spintronics expert.
Yeah, and okay. I want to add one thing here. This is the people who you want to do the research with in the second year. But if, for example, your research interest is more oriented to another topic that they are not researching, for example, you can also have the possibility of doing your research with a postdoc, or even with doing your research with another supervisor from another institute, but then you have to have a second supervisor here. I know there are some cases.
Yeah.
So, like, the flexibility is there and the possibilities are open. So, no problem.
Okay, so so next thing I want to say about is like, let's give some examples. So here's a student. These are real examples, by the way. So here's a student who has done his trajectory in high energy physics, essentially. So like he did his master's in high energy physics, his research in high energy physics, and here are the courses that he took. So general relativity, string theory, modeling, and simulation. So general relativity and string theory, of course, you expect that this guy is going to go into string theory, but at the same time, he's taking modeling and simulation. This is a possibility, and to leave these kind of possibilities open is always good, because if you really know how to model and simulate, in case you are not interested in string theory after you do your research, you have the option to go, just to maneuver around. You go somewhere else, do research somewhere else, or go to finance or something, whatever you want to do. So this will always help you with to build all your skills towards keeping in mind all kind of possibilities that you may do in the future. And so the examples in this trajectory that this person took was for the electives was topology and geometry from mathematics, and foundations of quantum mechanics is one elective that you can take, for example, from physics, but you can also take philosophy of space and time. That is, it's one elective from GSNS, from natural sciences. You can take also like something from biology if you want. This is one particular example. And finally, he did master's thesis with me on the aspects of quark-gluon plasma using string theory to understand the quark-gluon plasma. This is another example trajectory in low energy. So there's a mistake in the brackets with low energy physics. So this person has taken, so it all looks like, he's going to go to do, or she's going to go to high energy physics by taking, if you look at all these theoretical physics electives, but she chose to do correlation functions and topological insulators. But for this also, like all this stuff that she learns is quite important and useful, especially mathematics. Right. So this is, these are two examples. And maybe Ferran can say a little bit more about what courses have you taken? You already mentioned, right? So
I already mentioned. Yeah, basically I took high energy courses. General relativity, string theory, field theory, and particle physics. These are like the usual ones if you want to go into high energy, but then you can be more specific in other topics.
Okay, so finally, we have the extra options. So we have the options of doing, as I said already, you can go to a twin program, you can do double master's research in mathematics and physics. This is a possibility. You can do honors in I would say, few about more things about this, and you can have different kind of profiles within the same theoretical master's program. So the double masters is, as I said, if you're really ambitious, you can just essentially you can do it in 3 years most of the time. So every year counts for say 60 ECTS. So you do one more year, you take more courses, and also you do research also in mathematics. And you can do this. You can couple theoretical physics masters with any of the courses programs from Graduate School of Natural Sciences, like physics and mathematics is a possibility, physics and chemistry is a possibility. All these things are options are open. Or you can do honors, which are you can do, for example, honors in quantitative biology. So this is essentially following one course, and you can do honors in young innovators, graduate school, the graduate honors in interdisciplinary sciences, and etc. So you want to learn, if you want to know more about these options, especially about the honors, I invite you to look at this website that is written at the bottom of that second tab. So uu.nl/honors. And well, these are options outside of the theoretical physics program. Within the theoretical physics program, we have different options of choosing different profiles. So you can do, so as I already mentioned, kind of like two basic profiles, high energy physics and low energy physics, but you have on top of that, you have additional stuff, like for example, complex systems is a possibility. If you want to really apply your theoretical physics knowledge to real problems about, complexity in life, like traffic, finance, epidemics, all these kind of things, this is your chance. And while you can also say that I don't really want to do research, I want to go into education, and you can take you can do teaching, and you can take this profile to be formed essentially in for teaching in secondary education, and you get a certificate also. So this is a possibility. And then, or you can do applied data science, like big data, for example, is a very important thing these days. So this is you can learn theoretical physics knowledge to apply to artificial intelligence, climate physics, data science, business informatics, and all these kind of things are possible. Okay, so we are almost done. So these are the courses and plus the research. Well, it may be most of our students, like about between 60 and 70%, after their masters, they continue their academic career in physics, and so they go and do PhD. And most of them are successful in finding good PhD places within Europe or outside of Europe. And so this is the main thing that people do after graduation, but also the other options are also possible. So you can go to finance sector, you can go to IT and all these lists. I'm not going to go through this list. So you can go to this company. So if you get a master's, if you do a good master's in theoretical physics in Utrecht University, you have all these options open. And you can change your mind in the middle of your master. So this is what people do towards the end. They say, okay, so theoretical physics research is not for me. I'll just go and do journalism. That's a possibility. Okay, so that's it. So essentially, if you want to apply, please. Remember that the deadline for start in September for the non-EU members, students from non-EU states is earlier. It's 1st of April, and for EU states is 1st of June. So keep these dates in mind. If you want to start in February, that's also a possibility. You can start. You have the deadline is 1st of September and 15th of October for non-EU and EU. And entry requirements, you can learn more about this on the website. So essentially, you have to have some bachelor in physics or bachelor in science with strong component in physics. So how to define this precisely is on the website. If you have any questions, you can ask us. You can ask the program coordinators, me, and or Joost de Graaf. We are sharing the same coordinator email, so which is written here on your screen. And so please and also visit our website.
Yeah, and if you have any other question more related, maybe not only with the masters, but if you know that you are coming here, that you're accepted, and you have some doubts about things on the city of the university, we also have the possibility of contacting with me or Lotte or other students through the Unibody chat. Also in the webpage, you will find the direction, or maybe in the chat they can put it later on. So yeah, I think that's all.
Yeah. So thank you for your attention. So this is now we can have the question and answer session.
Okay.
Let's see.
So we have some questions here already.
Right. We already have some questions. Sure. So one, so one question Yefta is asking: is this master program much harder compared to the bachelor physics and astronomy in bachelors? Can you explain the main differences between them? Well, the main differences, it depends on how you define how it is really much harder. I think Lotte on chat can answer this question better because she has done bachelor's here in physics and astronomy in Utrecht University, so she can tell more about this. But what I can say from like the basic thing I can say is that, of course, you have to take a little bit more advanced courses like quantum field theory and statistical field theory and stuff like that. And on top of that, there is the research element, which is the difference so it's really not just taking a course and doing the stuff, but the research always requires creativity, and there are more unknowns there. So the second year will, depending on who you do your research with, it's a different thing. It's not just taking a course. So doing research, writing a thesis is not just taking a course. It's a completely different thing. So
yes.
You have to really think yourself. You have to own the problem. You have to do it yourself. Essentially, there's not going to be a supervisor, but it's not.
It's your own work.
You are mostly on your own.
It's a completely different work. Yeah.
All right. So right. So we got a question from Patrick. How does the pre-master's summer school work? Well, it's.
Okay. No,
you don't know. Well, you can read more about on the website, and if you have more questions, I can also answer this. So the way it works essentially is that so you have to. All these eligibility requirements, if you don't satisfy these eligibility requirements, what you can do is you can enroll in the pre-master's program, and then you essentially just take courses, and once you are done, you can start your master's. So this is, and if you have any more if you want to know a little bit, in more detail exactly what kind of courses that you take, and how does it work, how many hours that you have to spend, like the structure of this. So then I invite you to look at the website or just send us an email. Then I can give you in more detail, because here we have many more questions. Mm-hmm. So I hope that was good. So Leon asked the question: could you go more into detail about the double degree with mathematics? Right. So first of all, what you have to do is you have to take some courses from mathematics. So essentially you have to, from the practical point of view of a student, you have to have 60 more ECTS. Yes. So this 60 more ECTS means that you have to, some part of this ECTS is your extra research that you have to do, and on top of that you have to take more courses. So you have to take more mathematics courses, which you can choose. Okay. And then you have to decide essentially, okay, so like this is the subject that interests me. So for example, I'm really interested in the bifurcation theory. Okay. And at the same time, I'm interested in theoretical physics. So what can I do? So I can tell you, for example, you come and you talk to me. I say, okay, I don't want to do bifurcation. This is a real example, by the way. And but I don't want to go out of physics. So I want to really stay in physics and do bifurcation theory and graph theory and all that thing. So one option is that we find a common ground, right? So this is a possibility. So this guy, my last year's master's student, came to me and he wanted to do bifurcation theory and he wanted to apply this to quantum field theory. And yes, that was possible to study RG flows in quantum chromodynamics using the bifurcation theory. So this is one option. Another option is that if you cannot really find a common point, a common ground between theoretical physics and mathematics, you may be more mathematically oriented, but at the same time want to learn about theoretical physics. This is possible. So you will be, your focus will be really in mathematics mostly. You will essentially, you also have to do some research in theoretical physics as well, but you can do two different subjects. You can do mathematics and you can do physics research at the same time. So they will be, of course, smaller in size in terms of like, final output, your report. But yes, so these are this is how it works essentially. So then you have to stay one more year. It's impossible to do all of this in 2 years. So you have to do more research, you have to take more classes. So yeah, this is how it works. And if you are really interested in, well, again, as I said, like we can answer more detailed, specific questions by email. So Sebastian asked, why do employers hire theoretical physics students in fields like finance, consultancy, etc.? I asked myself too. I don't know.
Well,
I mean,
I think
maybe Ferran knows better.
I think I can answer this because my father works in a company, and he always says that they hire a lot of physicists, especially theoretical physicists and mathematicians, not only because of their knowledge, but especially for the work, the way they have trained their brain to work, like the way you're used to face a problem and to find new solutions. This is really an important thing for companies.
Yeah, exactly. So essentially, well, I mean, I was joking when I said. So the one thing that when I did my PhD, half of my friends went to finance. And of course, I was asking this question to myself, but why do finance people want to hire physics colleges? Because what we do in PhD or masters is that we are given a problem, as Ferran said, we are given a problem, and whatever the problem is, we are supposed to solve it in some way, and we have to be, really, we have to both have talent and the right skills and just the information, knowledge on how to attack a problem, and all these kind of things that This is where it's not really just a routine work that we do, right? So this is what we are good at, to find any kind of problem that you have to just structure your approach to problem. So this is, I think, like what physicists are good at.
Yeah. Okay, so Francisco has a question: how difficult is to find good housing in Utrecht? Okay, this is a good question. Well, it's not easy, and but in general, it's not easy in the Netherlands, not in Amsterdam, not in Utrecht. It takes a bit of time and patience. So in the beginning, for me at least, it took a month, more or less, of not having a fixed place. But then if you are patient and you keep watching, then you'll find something, that for sure. But in the beginning, yeah, in the beginning can be a bit frustrating, but please don't let this make you change your mind, because it's worth it. Utrecht is really nice to live.
So it's not that we have students who are opening tents on campus. So like finally everybody gets housing. Don't worry about
yes.
It. Okay, so we have another question from Patrick. Do master students work as teaching assistants?
Well, I can answer this. Yes, especially in the second year, but also in the first year. Yeah, you can work as teaching assistant, like. The same thing that we talked before on the problem sessions, that you have PhDs helping you. You can also help bachelor students, and then you obviously get paid for it. So it's really nice, really nice work.
All right.
More question.
Yeah, we have a question from Leon. How many people are taking the double degree? Good question. Actually, do I have the numbers? I think every given year is about like 10% of the students, or maybe more. Do you know?
No, I think more or less 10%.
It's about 10%. Yeah. It's about 10% of the people, and most of them, like almost all of them, are doing double degree in physics and mathematics. So, but as I said, if there is the possibility to do, if you're interested in whatever theoretical biology, then you can do theoretical physics and biology at the same time. So that's a possibility. All right.
Okay.
Okay. So I think, well, I think we are done. So thank you very much for your attention. So if you have any other questions, please just contact us by email. And maybe you want to say also the Unibody.
Yes. Well, I said before, but if you
again, let's remind you.
For the Unibody tab in the web page, both Lotte or me can answer, or any other student for different masters can answer your questions. So,
okay. Yeah. Thank you very much.
Thank you.
Good luck.